There is a river flowing 30 meters underwater in Mexico, and it has its own banks, its own fog, and trees that fell into it thousands of years ago. That sentence is accurate. No metaphor, no editorial license. A fully formed river submerged inside another body of water, with a surface you can see but cannot feel because it is not solid. It is a halocline, the razor-thin boundary where freshwater meets saltwater and refuses to mix. This is where the episode begins, and it is also how the episode works. 13 places. Each one looks wrong at first glance. Each one is exactly right on closer inspection. Right in the sense that it follows physical laws with perfect consistency, which somehow makes it stranger, not less strange. The cenote in Yucatan produces its river effect because fresh groundwater and salt intrusion from the sea have different densities and different refractive indices. The mist hovering above the halocline is an optical distortion. The submerged trees date back to an era when sea levels were lower and those limestone caves were open air. None of this requires fiction. The same logic applies to the other 12. A pink lake in Australia holds its colour in every light condition because of a specific strain of halophytic bacteria and a high concentration of brine. A beach in the Maldives lights up in blue at night because of bioluminescent plankton responding to wave pressure. A desert in white sands contains transparent freshwater pools among gypsum dunes. A cave in Vietnam, Son Dung, is large enough that clouds form inside it. Basalt columns on the northern coast of Ireland cooled 60 million years ago into hexagonal geometry so consistent it looks engineered. Not one of these is an anomaly or an exception. Every item on this list is a documented, visitable outcome of processes that predate human civilization by geological orders of magnitude. The episode will show you what each one looks like, explain why it happens, and leave you with a specific discomfort. The world was doing extraordinary things long before anyone was here to call them extraordinary. The ocean is alive, and on one particular beach in the Maldives, it refuses to let you forget that. Number 13 on this list is Vadhu Island in Rar Atoll, where the shoreline glows electric blue after dark. Not because of lighting rigs, drone footage tricks, or tourist infrastructure, but because of single-celled organisms you cannot see with the naked eye. Dinoflagellates are microscopic plankton with an extraordinary biochemical capability. When physically disturbed, they emit light. A wave crashes, a foot presses into wet sand, a fish cuts through the shallows, and cells ignite, releasing photons in milliseconds. The evolutionary logic is defensive. A sudden flash startles a predator, giving the plankton's host organism a chance to escape. But scaled up to the density of a coastal bloom, what began as a survival reflex becomes one of the most surreal visual phenomena on the planet. The effect only works under the right conditions. Moonless nights eliminate competing light. Warm season water temperatures support higher dinoflagellate concentrations. The absence of artificial light pollution allows the blue to register fully. Even then, the bloom is variable and unpredictable, dense enough to glow brilliantly one night and barely visible the next. That instability is part of what makes an encounter with it genuinely rare. Vadhu is a small inhabited island, home to a few hundred residents, for whom this spectacle is simply a feature of local geography. The photographs that spread globally in the early 2010s made this shoreline iconic, a symbol of the ocean's hidden biology. One important distinction: the bioluminescence itself poses no harm to humans. The same dinoflagellate species, under different conditions, can produce toxic red tides, but Vadhu represents the phenomenon at its most benign and most beautiful. This is where the list ends, with darkness, with invisible life, with light that comes from within the water itself. The water stays pink in a bottle. That's the detail that stops people cold. Not the aerial photographs, not the satellite images, but the simple fact that if you scoop up water from Lake Hillier on Middle Island in Western Australia and hold it up to the light, it doesn't look clear. It looks like strawberry milk. Rank 12 on our list is a lake that refuses to behave like water is supposed to. The color isn't a trick of depth or sky reflection or a particular angle of afternoon light. It is permanent, consistent, and entirely biological. Lake Hillier sits on a narrow strip of land barely separated from the Southern Ocean by a white sand beach and a band of dark eucalyptus forest. Most people who have seen it have never stood beside it. The island is a protected nature reserve with no regular access, so the view almost everyone gets is from above, from a helicopter or light aircraft, looking down at a perfectly circular disc of bubblegum pink surrounded by green and white. That color comes from a collaboration between two groups of organisms that thrive where almost nothing else can. The water's salinity rivals the Dead Sea, and under that extreme salt stress, the microalgae Dunaliella salina ramps up its production of beta-carotene, a pigment in the orange-red spectrum that saturates the water from within. Alongside it, halophilic bacteria add their own pink and red compounds to the mix. Together, they run a continuous biological dye operation on a scale visible from orbit. When the first European expedition documented the lake in 1802, during Matthew Flinder's coastal survey, the observers had no framework for what they were seeing. Their notes register genuine confusion. For the next 2 centuries, theories circulated: iron oxide, unusual mineral salts, exotic algae. But the precise biochemical mechanism wasn't confirmed until the 21st century, when DNA analysis of the microbial community finally closed the case. The lake is harmless. Humans can swim in it without any risk. Getting there is the hard part. The next wonder on this list also transforms its environment with color. But unlike Hillier's fixed and permanent pink, it answers to the seasons, appearing and vanishing on a cycle older than any human witness. The ground here is red, not at sunrise, not through a filter, not because of algae or iron oxide or any kind of contamination. The ground is red because the plants decided to make it that way. Every autumn, across the wetlands of Panjin in northeastern China, millions of Sueda salsa plants shift from green to a deep arterial crimson. And the result is one of the most disorienting natural landscapes on Earth. This is number 11 on our list, Panjin Red Beach. The mechanism behind the color is biochemical. Sueda salsa is a halophyte, a plant adapted to survive in conditions that would kill most vegetation. The Liaohe River Delta, where Panjin sits, is an ecotone, a collision zone between freshwater river flow and saltwater tidal intrusion. As autumn temperatures drop and soil salinity rises, the plant responds by producing anthocyanins, the same pigments that turn maple leaves red in fall. Because Sueda grows low and dense, spreading laterally across the ground rather than upward, it coats the entire surface in a single, unbroken sheet of color. No gaps, no variation, no gradients, just red stretching to the horizon. Panjin is also one of the most important breeding and stopover sites for the red-crowned crane, Grus japonensis. With a global population estimated at somewhere between 1,500 and 2,000 individuals, this is one of the rarest birds alive. The cranes feed and nest here during migration, and the image of white birds moving across a red marsh is not easily forgotten by anyone who has seen it. The ecosystem faces real threats. Oil extraction operates within and adjacent to the delta. Industrial development has altered drainage patterns. The protected reserve holds the line, but not everywhere and not without cost. The balance here is not stable. It is managed carefully against constant pressure. From a coastline where biology writes itself in color, we move next to a lake that stays pink, not for a season, but permanently, year-round, regardless of weather or light, for reasons that have nothing to do with plants at all. A desert that fills with fish every year sounds like a myth. It isn't. At Lençóis Maranhenses National Park, Ranked 10th among the world's most astonishing places, the sand itself incubates life through months of brutal drought and releases it the moment rain arrives. The park sits in Maranhão State, northeastern Brazil, wedged between the equator and the Tropic of Capricorn. Its 1,500 square kilometers of blinding white quartz dunes look, from above, like a vast, crumpled bedsheet, which is exactly what Lençóis means in Portuguese, sheets. Between January and June, roughly 1,200 millimeters of rain fall across this landscape. That figure matters because it technically disqualifies the region from being classified as a true desert. And yet it behaves like one because the quartz sand is so porous that surface moisture simply vanishes.
It doesn't evaporate, it sinks, traveling downward until it meets an impermeable rock layer, where it pools and slowly feeds thousands of lagoons that form in the low valleys between dunes. The water that surfaces there is fresh, startlingly clear, and unexpectedly cold, tinted in shades of tourmaline and aquamarine, depending on depth and light. By August, those lagoons have nearly disappeared. The dunes return to their scorched, lifeless state. This cycle has been repeating for millions of years. The fish reappear because their eggs never left. Wolfish and piranha deposit eggs in the wet sand before the dry season closes in. The eggs remain dormant through the heat, preserved in the quartz, and hatch within days of the first rains. The desert was never truly empty. It was a waiting room. The park was established in 1981 to protect this singular hydrological phenomenon along the Atlantic coast. Visitors reach the lagoons on foot or by four-wheel drive across burning sand, and swimming in those sky-blue mirrors surrounded by white dunes is not an optional excursion. It is the entire point of being there. These mountains are not painted. That sounds obvious until you actually see them. Stripes of crimson, orange, yellow, green and violet stacked across entire hillsides with a precision that seems to defy geology. Number 9 on our list is Zhangye Danxia Geological Park in Gansu Province, China, and the reason it looks the way it does is a 24 million year accumulation of sedimentary rock loaded with iron, manganese, copper and other minerals. Here is how it works. Over tens of millions of years, mineral-rich sediments built up layer by layer, each stratum representing a distinct geological epoch, a different climate, a specific chemical environment. Tectonic forces then lifted the entire mass, and erosion stripped away the surface, exposing cross-sections of deep time. Red comes from iron oxides. Green is chlorite and mica. Yellow appears where iron has oxidized at different valence states. Each color band is a chemical signature, a readable record of conditions that existed long before anything resembling human civilization. The appearance shifts with light in ways that reward patience. At dawn, the slopes burn like heated metal. By midday, the same surfaces fade toward pastel. After rain, saturation spikes to levels that make photographs look digitally enhanced. They are not. This is why most iconic images of Danxia were shot within minutes of a storm clearing. The wet rock returns its full chromatic intensity before it dries. Zhangye sits along the route of the ancient Silk Road, and these ridgelines served as navigational landmarks for trading caravans for thousands of years. The UNESCO World Heritage designation came in 2010, recognizing Danxia as part of a broader category of Chinese landscapes, defined by this particular combination of geology and color. If Lençóis Maranhenses, the previous entry, regenerates itself seasonally through wind and water over weeks, Danxia operates on a timescale with no human equivalent. What you are seeing is 24 million years translated into color, a working textbook of tectonics and geochemistry visible from the surface without a single instrument. Next on the list, a place where geometry itself seems to break the rules. There is a waterfall off the coast of Mauritius that does not exist. Satellites photograph it. Helicopter passengers film it. Scientists have verified it. And yet the ocean floor beneath it has never produced a single drop of falling fresh water.
What the camera sees and what is actually happening are two completely different events, and the gap between them is the reason Le Morne-Brabant's underwater waterfall ranks 8th among the most extraordinary natural optical phenomena on Earth. The mechanism is geological, not magical. Mauritius sits on a particularly narrow continental shelf, where most islands are cushioned by hundreds of kilometers of gradually deepening sea floor. Here, the shelf drops off sharply, just a short distance from shore, plunging thousands of meters into the deep ocean basin. Strong underwater currents perpetually sweep fine white coral sand and silt across the shallow plateau toward that edge. At the rim, downwelling currents catch the sediment and send it cascading down the vertical submarine cliff face. From altitude, this continuous stream of pale suspended material flowing against a near-black deep-water backdrop is visually indistinguishable from falling water. The illusion holds because of contrast. The shallow lagoon above the shelf glows turquoise and green in the tropical sun. Warm, clear, full of light. The deep zone beyond the drop is almost opaque with darkness. The sediment plume connects these two worlds like a curtain torn loose from the ceiling. The brain, encountering this configuration, does what brains do. It finds the most familiar pattern and commits. Waterfall. The stronger the currents run, the more convincing the image. And around Le Morne, the currents almost never rest. The peninsula carries a second identity that no satellite image can capture. These basalt cliffs were the last refuge of escaped slaves during the French colonial period. Men and women who climbed here because the rock offered what the plantation system refused them. UNESCO designated Le Morne-Brabant a World Heritage Site in recognition of that history, a monument to resistance and memory. The same coastline that stages nature's most persuasive illusion once sheltered the most desperate acts of human defiance. A mountain range was swallowed by the sea 300 million years ago, and what you see today in Zhangjiajie is what the sea gave back. Number 7 on our list, the stone pillars of Tianzi Mountain, Zhangjiajie National Forest Park, Hunan Province, central China. The paradox is worth sitting with. These columns, more than 3,000 of them, rising vertically from a 430 square kilometer park, were not pushed up from below. They are what remains after everything around them eroded away. During the Devonian period, this entire region lay beneath a shallow ancient sea. Layers of quartz sandstone accumulated under water pressure over millions of years, compacting into exceptionally hard rock. Then, tectonic forces lifted the land. Rain followed, wind followed. Freeze-thaw cycles fractured whatever was softer. The softer rock vanished, the pillars stayed. Geology did not build them so much as it revealed them. Most pillars exceed 200 meters in height. Several approach 400. Their surfaces are nearly vertical, yet dense vegetation clings to the tops. Trees and shrubs rooted in thin soil on what should be impossible ground. On mornings when low cloud fills the valleys between the columns, the peaks appear to detach entirely from the earth and drift above a white floor of mist. The visual effect is not subtle. In 2008, concept artists working on James Cameron's Avatar used this precise image as the template for the Hallelujah Mountains of Pandora. The fictional floating rocks and the real ones share the same geological logic, or rather, the fictional ones borrowed it. One peak in the park was subsequently renamed Avatar Hallelujah Mountain, a natural object rechristened after the cinematic image it had unknowingly authored. In 2024, approximately 34 million people visited the park. The infrastructure built to handle that number, glass bridges, cable cars, the Bailong elevator, the tallest outdoor lift on Earth, is visible and permanent.
The tension between geological heritage and tourist throughput is not resolved, it is managed. But the pillars themselves are indifferent to the management. They were here before the Devonian Sea filled in around them, and they will be here in forms we cannot predict, shaped by processes that do not pause for visitor counts. Next, number 8. Off the coast of Mauritius, the ocean appears to be falling into itself. 37% of Socotra's plants grow nowhere else on Earth. Neither do 90% of its reptiles, nor 95% of its land snails. Those numbers are not the result of careful conservation or deliberate protection. They are the consequence of 6 million years of almost total biological isolation, and they place this Yemeni archipelago, ranked 6th on this journey, among the most singular places on the planet. Socotra sits in the Arabian Sea, roughly 240 kilometers from the Yemeni coast and an equal distance west of Cape Guardafui at the Horn of Africa. It consists of 4 main islands and several smaller rocky outcrops. When the landmass broke away from the supercontinent Gondwana 6 million years ago, evolution was left to run its own experiment in near-complete seclusion. The dragon blood tree, Dracaena cinnabari, is what that experiment looks like. Its crown is wide, flat, and circular, shaped less like a typical tree and more like an open umbrella frozen in place. That geometry is functional. In an environment with severe water scarcity, the canopy intercepts morning moisture and directs it downward along the branches and trunk to the roots below. When the bark or a branch is cut, the tree releases a thick, dark red resin that locals have called dragon's blood for centuries, using it in traditional medicine as a dye and in ritual practice. Standing on the Dixan Plateau, surrounded by hundreds of these trees against a sky softened by mist, many visitors describe the experience as looking at a landscape from another world. That description is scientifically defensible. UNESCO recognized Socotra as a World Heritage Site in 2008. But recognition does not equal protection. The armed conflict in Yemen, increasingly frequent tropical cyclones, and growing tourist pressure now converge on an ecosystem that has no resilience to rapid disruption. What took millions of years to build can be undone in decades. Socotra is a living argument for what isolation does to evolution. The next location on this list makes that argument underground, in the darkness of the largest known cave system on Earth. There is a place on Earth where clouds form underground, not as a metaphor, not as a trick of the light, actual clouds drifting slowly beneath a stone ceiling hundreds of meters above the cave floor. This is Son Jong, number 5 on this journey, and it is the largest cave in the world. Located in Quang Binh province within the Phong Nha Khe Bang National Park of north-central Vietnam, its main passage stretches nearly 9 kilometers, rises up to 150 meters high, and spans 200 meters wide. To put that in terms the human brain can process, a 40-story skyscraper would fit inside with room to spare, and you could line up several city blocks beside it. The clouds exist because of the cave's sheer scale. Warm, moisture-laden air rises toward the vaulted ceiling, cools, and condenses. The system is large enough to sustain its own microclimate, independent of the world outside. In several places, ancient roof collapses created vertical shafts, skylights, through which columns of daylight pierce the darkness. Beneath them, isolated jungle ecosystems have taken hold. Trees, ferns, and mosses up to 30 meters tall, fed entirely by the light streaming in from above. Species of fish and insects found nowhere else on Earth have adapted to life in that half-lit underground world. The cave floor holds formations called cave pearls, massive calcite structures reaching 7 meters in height, with no comparable equivalent documented anywhere on the planet. None of this was formally confirmed until 2009,
when a joint British-Vietnamese team from the British Cave Research Association, led by Howard and Deborah Limbert, completed the first full survey. A local farmer, Ho Can, had stumbled upon the entrance back in 1991, but turned back, deterred by the wind rushing out of the darkness and the sound of an invisible river below. He had found the door to the largest hollow space on Earth and chosen not to go in. Today, access remains tightly controlled. Only a few hundred visitors are permitted each year, each requiring specialist equipment and advance authorization. Son Jong is not a ruin or a static formation. It breathes, it grows, it changes. That quality of a living system rather than a spectacle is what separates it from almost everything else on this list. From the hidden depths of the Earth, this journey now rises toward the surface, where nature abandons subtlety entirely. Next, the Socotra archipelago, the so-called Galapagos of the Indian Ocean. A forest does not survive underwater for over a century. That is not how forests work. And yet, at number 4 on this list, there is a lake in Kazakhstan, where more than 100 years after a catastrophic earthquake, the trees are still standing, rooted in the lakebed, trunks rising toward the surface, some reportedly still holding their bark and needles in the frigid darkness below. Lake Kandy sits in the Tian Shan Mountains of southeastern Kazakhstan, roughly 2,000 meters above sea level. The lake did not exist before January 4th, 1911. On that date, an earthquake now known as the Kemin earthquake struck the region with a magnitude estimated around 8. A mountainside gave way, sending rock and earth crashing into the canyon of the Kandy River and sealing it shut. Water began to fill the valley behind that natural dam. The spruce forest standing there had nowhere to go. It was not knocked over, not swept away. It simply drowned in place, standing upright, the same way it had grown. What happened next is what makes this place scientifically remarkable, rather than merely visually striking. The water in Lake Kandy is extraordinarily cold. Temperatures rarely climb more than a few degrees above freezing, and in winter the surface seals under thick ice. In these conditions, the biological machinery of decomposition has almost no fuel to run on. Bacteria slow down. Fungi cannot take hold. The wood does not rot. The lake has functioned, in effect, as a natural preservation chamber, holding the forest in a state suspended between life and decay for more than 100 years. Above the waterline, the trunks have been bleached and stripped by sun and wind into pale silver columns. Below it, divers report encountering something closer to the original forest. Bark still clinging to the wood in places, the ghostly outlines of submerged crowns hanging motionless in water so cold it discourages any prolonged exploration. For those who dive here, the experience reverses normal spatial logic. The forest surrounds you, but you are inside the water, not inside the trees. The sky exists, but only as a distorted shimmer far overhead. This is what it looks like when a single geological moment refuses to let go, a catastrophe preserved at the exact instant it occurred. The next location on our list shifts the scale entirely. Beneath the jungles of Vietnam lies a cavity so vast it generates its own weather system, its own clouds, and its own forest, all contained within a single cave. Nature built a perfectly tiled floor 60 million years before humans invented geometry. That is not a metaphor. At number 3 on our list, on the northeastern coast of Northern Ireland in County Antrim, roughly 40,000 basalt columns rise from the sea and fit together so tightly, with such regularity, that the structure looks less like a geological accident and more like the work of an obsessive master mason. This is the Giant's Causeway, and the precision is real. The explanation begins with a catastrophe. Around 60 million years ago, a massive basaltic eruption sent superheated lava pouring across this coastline. As the molten rock began to cool, something counterintuitive happened. The more slowly and evenly it cooled, the more orderly the outcome.
Uniform contraction generates uniform stress, and uniform stress fractures rock along a predictable geometric grid. The result is hexagonal prisms, columns that share walls with their neighbours and leave almost no gap between them. Most of the columns here have 6 sides, though 5- and 7-sided forms appear throughout. The tallest reach 12 metres in height and descend directly into the Atlantic, forming what looks unmistakably like a paved road disappearing beneath the waves. UNESCO recognised the site as a World Heritage Landmark in 1986. Long before that designation, Irish mythology offered its own structural engineering report. The giant Fionn McCool built the causeway to march across to Scotland without getting his feet wet. The legend turns out to be geographically interesting. On the Scottish island of Staffa, an almost identical basalt formation exists. This is not coincidence dressed up as folklore. Both sites are remnants of the same ancient volcanic event, now separated by the sea that has been slowly dismantling them ever since. From this coast, where physics once expressed itself in stone with unusual clarity, our list moves east and inland, to a mountain lake in Kazakhstan, shaped by a very different kind of geological violence. These trees have been dead for 900 years, and they're still standing. That's not a metaphor or an approximation.
The camel thorn acacias rooted in the white clay floor of Dedvley in Namibia's Namib Desert died around the 12th century and have not fallen, rotted, or decomposed in any meaningful way since. The reason is ruthlessly simple. The desert won't allow it. Humidity in this basin is so negligible that the bacteria and fungi responsible for organic decay cannot function. Without decomposition, the trunks remain upright, blackened not by rot, but by 9 centuries of ultraviolet radiation that has effectively carbonized their surfaces. What you see standing in Dedvley are not ruins. They are the original trees, preserved by the same environment that killed them. The death sentence came when the surrounding dunes, which reach heights of up to 300 meters, blocked the course of the Tsauchab River and severed the basin's water supply. Those dunes are the tallest orange sand dunes on Earth. Their color produced by iron oxide that has been accumulating in the sand for millions of years. This is the same compound that gives rust its color, concentrated here into walls of deep ochre that enclose the white clay pan on every side. The visual logic of Dedvley operates entirely on contrast. Black skeletal forms against white clay against orange dunes against a blue sky with no clouds to interrupt it. There is no vegetation, no movement, no sound. Surface temperatures on the clay floor exceed 60 degrees Celsius at midday in summer. The site is unreachable by vehicle. The only way in is on foot across the dunes. Photographers from around the world schedule expeditions specifically for sunrise here, when the contrast between the layers of colour is at its most extreme.
Dedvley ranks second among nature's most astonishing displays of suspended time, a place where 9 centuries have passed and almost nothing has changed. There is a river at the bottom of a lake in Mexico, and it is not a metaphor. Divers who descend 30 meters into Cenote Angelita near Tulum on the Yucatan Peninsula find themselves hovering above what looks unmistakably like a river. Defined banks, drifting fog, submerged trees along the edges, leaves moving with what appears to be a current. The photographs have been dismissed as composites for decades. They are not. The explanation begins with geology. The Yucatan Peninsula is a vast limestone shelf, and for millions of years, rainwater has been dissolving it from within, carving out underground rivers, chambers, and passages. When a chamber ceiling collapses, it opens a cenote, a roughly circular window into that subterranean network. The Maya considered these openings sacred thresholds into Xibalba, the underworld. Cenote Angelita looks ordinary from the surface. Calm, clear, fresh water, light filtering through the canopy above. The strangeness begins at depth. Organic matter, leaves, branches, decomposing animals, accumulates on the floor and produces hydrogen sulfide gas. Hydrogen sulfide is denser than water and does not mix with it. Instead of dispersing, it settles into a horizontal layer roughly 2 meters thick, suspended between the fresh water above and the salt water below. Salt water that has migrated inland through the porous limestone from the Caribbean coast. That layer is not transparent. It forms a pale, opaque cloud with a perfectly flat upper surface, and that surface behaves like water. Disturb it with a hand and it ripples, then slowly closes. From above, the layer reads as a riverbank landscape, complete with fog and shoreline. The hydrogen sulfide is toxic, so reaching this depth requires careful dive planning and appropriate equipment. But the phenomenon itself exists because Angelita is a closed system. No wind, no current, no mixing. The physics and chemistry here are running without interference, and they have accidentally produced something that the human visual system has no framework to correctly interpret underwater. A gas pretending to be a river. An underwater world performing the surface world back at you. The planet doesn't need your imagination. It stopped needing it a long time ago. 13 places exist on Earth right now that no human mind would have invented. Because the human mind tends toward the plausible, the familiar, the logically constructed. Nature has no such constraints. A beach that burns blue at night in Indonesia is not a metaphor. It's sulfuric gas igniting at the surface of volcanic cracks, producing cold blue flame that moves with the waves.
A lake in Western Australia is permanently pink, not seasonally, not occasionally, but every single day, because a salt-tolerant microorganism called Dunaliella salina produces carotene in concentrations that dye the water the color of bubblegum. These are not optical illusions, they are chemistry. The same logic applies to the white sand dunes of Lençóis Maranhenses in Brazil, which look exactly like a desert, but receive more than 1,500 millimeters of rainfall per year. The rain collects between the dunes in turquoise lagoons that appear and vanish on a seasonal schedule. The causeway in Northern Ireland is 60 million years of slow-cooling lava that cracked into near-perfect hexagonal columns because basalt, under the right pressure and temperature, finds geometry. The flooded forest of Sumidero Canyon has been underwater for over a century. The trees did not die. Paradox is not a rhetorical device here. It's the actual condition of these places.
They exist in contradiction with what we expect from the natural world, and that contradiction is not an error. It is the point. 13 entries, 13 arguments that the Earth produces the impossible as a matter of routine. We arrived late to all of it. We are, at best, incidental witnesses, and that is not a diminishment. It might be the most honest relationship we can have with a planet that was never ours to begin with. Pick one place from this list, the one you want to see while you still can. Leave it in the comments.